Okay, so in this video, we're going to be looking at negative indices. But before we do that, I just wanted to touch on one of the exponent rules that you may have come across in 7.2. And that is anything to the power 0 is equal to 1. That is any number or variable raised to the power or index of 0 is equal to the number 1. And I just wanted to look at that briefly for you. So if I were to have, for example, a to the third power divided by a to the third power. Now, let's just look at what that really means. If I look at that in its expanded form, it's really a times a times a divided by a times a times a. And if I were to do a bit of cleaning up or reducing, canceling, all these a's would cancel, leaving me with 1 over 1, which is really just 1. But I also know that from 7.2, the rules for indices say that if I am dividing, do you remember? I subtract the indices, which means that that becomes a to the 0 power. So same question, I've just worked it in two different ways. One way was first looking at the expansion, and the other way was using my laws of indices. And I just want to point out that I got two different answers. Now you might think they are two different answers, however, they are actually the same thing. And that is where the rule is coming from. Any number or variable to the power of 0 is equal to 1. So this pretty much gives me the rule a to the 0 is equal to 1. Similar to what we have in our book, in the textbook, which is x to the 0 is equal to 1. Now, in the same breath, I could say the number 5 to the 0, that is still equal to 1. 10 to the 0, that is also equal to 1. So I just wanted to make that clear before moving on. So that's one of the other rules. So now we can say pretty much technically we have 4 rules for indices that we have covered so far. I just wanted to touch on now negative indices. Let me clean this up just a little bit, give us a little bit more space. And now we're going to be touching on negative indices. Now, when looking at negative indices, I do want to start out the way we've been starting out by looking at an example and kind of proving these by examples. All right, so let's start out by looking at a to the second power divided by a to the third power. Now, we know our laws of indices. We looked at that in 7.2, and when dividing, we subtract our indices. When dividing, we subtract our indices, which gives a to the 2 minus 3. Let's just write that 2 properly. A to the 2 minus 3, which gives a to the negative 1. But what does that really mean? In order to get an idea as to what that means, we're going to look at it in its expanded form. And the expanded form is really a simplistic way of looking at indices, just trying to prove those rules. Okay, so if I have a squared divided by a to the third power, that is really a times a divided by a times a times a, which if I do a bit of canceling and reducing, that a can cancel with that a, and that a can reduce with that one, which gives me 1 times 1 is 1 over 1 times 1 times a happens to be a. Now, let's do that comparison as we did with the rule above. We have a to the minus 1, and we have 1 over a. And those two things are equal. So a to the negative 1 is really equal to 1 over a. And I'll just put that power of 1 there because I know that is understood. Now, when looking at negative indices, it is very important to remember that nothing is negative in your answer, but that it produces a fraction. So let's look at a few more examples. A to the negative 2 is really 1 over a squared. Similarly, a to the negative 3 is 1 over a cubed. And that's how we come up with our general formula of a to the negative n is really 1 over a to the n. Okay? So just want to go over that briefly. Any base to a negative exponent does not give a negative result. It gives a fractional result. That's important. So a to the negative 1 is really 1 over a to the power of 1. A to the negative 2 is really 1 over a squared. A to the negative 3 is really 1 over a cubed. All right, just want to make that clear. All right, so let's jump right into our examples. Now, what about 3 to the negative 2? Now, let's refer to our examples here. Remember, we said nothing is going to be negative in my answer. That is actually going to give us 1 over 3 squared. Very good. Now, let's calculate, because that is what the instruction said. Calculate. So I have to actually work that exponent out. And that gives me 1 over 3 squared is not 6. It is 9. Very good. So that is my final answer. Good. Now let's look at 2 to the negative 1, subtract 4 to the negative 1. And this one might look a little complicated, but let's take it step by step. So what is 2 to the negative 1? That is really 1 over 2 to the 1. But I don't have to write that one there. We know it's there. All right, and 4 to the negative 1 is really 1 over 4 to the 1. But I can do without writing that one. And now I have two fractions to subtract, which is 1 over 2 minus 1 over 4, which is a half minus a quarter. Now, I should be able to do that mentally. A half minus a quarter is really just a quarter. Very good. Now, I'm not sure. I'm actually going to do a bit of extension with this question and say I could also rewrite a quarter as 4 to the negative 1. That's what I had up there. Very good. But that was just a bit of extension if you wanted to take it that far. Okay, and write it in index notation. And the last part of the question for example 1 is 5 to the negative 3. And that is actually equal to, remember we said nothing is going to be negative in my answer, but it's 1 over 5 to the third power. Now, what is 5 to the third power? Hope no one is saying 15, because remember we said 5 to the third power from video 7.1 is 5 times 5 times 5, which happens to be 125. So it's 1 over 125. Yes, yes? Okay, let's jump right into example 2. So this question is asking me to simplify. Let's make sure to read the instructions. And it says 6 to the 7th power divided by 6 to the 9th power. Now, using our laws of indices, I know for sure that I get, what do I do with my indices? I subtract, which gives me 6 to the negative 2. But I can rewrite 6 to the negative 2 as a fraction, because I just learned about negative indices, and that really is 1 over 6 squared. Now, the question did not ask us to calculate, it asked us to simplify. So if you wanted to leave it in any one of these two steps, that would have been okay. But if it said calculate, you would take it a step further to evaluate 6 squared. But because it only says simplify, I'm going to leave it in that form. Okay? All right, so let's move on to second example. 6 to the 4th times 6 to the negative 3. Now, what do I do with indices when I multiply? What do? Very good, I add. But now I'm adding a negative number. What is 6 plus negative 3? Of course, that is really 6 to the power of 1, because that is 4 minus 3. Those two signs come together and it's a minus. Very good. And 6 to the power 1 is really just 6. We want to simplify that all the way. Very good. And our final example for this video is 10 squared raised to the power negative 3. Now we have to remember our laws of indices from 7.2, because what are we going to do with those two indices? We are going to, very good, we're going to multiply. So that's 2 times negative 3. And what is 2 times negative 3? 10 to the negative 6. Very good. And that's going to be rewriting my negative indices 1 over 10 to the 6th power. Now that was pretty intense. I hope we got all those laws of indices down, and I hope we have an understanding of the negative indices. Good luck on your exercise.